And today in the workshop I've got another jukebox. This one is a Wurlitzer Niagara 2, condition unknown, bit of an enigma. According to the service manuals it's an all electronic jukebox from late 70s, early 80s. However, this one's not all electronic, it's missing the display. So this is actually, I think, off an earlier original Niagara, and they've seemingly used leftover parts. So the first thing to deal with is a snapped off key. To get some tools on this already. Yes, I've just managed to turn the key. Luckily it's now unlocked. This door's very heavy. I'm pretty sure the gas springs are gone. Chop this up. Hopefully that stays there. Right, it doesn't look too bad inside. First things to do is get this knackered gas strut off here. Still got a little bit of pressure left in it. There we go. Gas struts are quite common, you find them everywhere. The boot lids of your car and the bonnet, all sorts. And also jukebox lids. This one's actually rated for a force of 270 newtons, which is about 27 kilograms. And there's no way it's got that in it anymore. Fortunately, they're quite cheap. So I've managed to get a replacement one that's rated at 300 newtons, close enough, about £12 delivered. Incredible. With the new gas strut, floats up all on its own. It's time to power this up, see what happens. It's a reassuring buzz or a hum coming from the amplifier. I don't know if there's a lamp in here that's gone or a lazy starter, I'm not sure. Just going to get it to play something. Say 1A. Well, we've got good action. Well, that's encouraging. Right, load some records in. Let's try one of them. Let's try it. 0A. Looking good so far. Well, it's basically working. It's a bit muffled, I'm not sure what that is. I'm going to check the amplifier out. And do a bit of a test of the speakers, see if they're working nicely. As it's basically working, it just needs a good service. So I'm going to attack all of the switches and contacts that are going to have gone all manky and corroded over the years. Got to remember this thing's 40 years old, so all the brass contacts are going to turn black. It's going to do things like the carousel's going to miss the odd record or skip past it. You just need to clean the contacts, but they're all buried underneath. First of all, we want to take this plate off here. I don't know if it actually serves much purpose other than indicating the amount of times the record's been played. Just lifts off. Little wing nuts off here. We can unload our records as well before we get those damaged. This just lifts away. Take the bolt out of there and that tube comes off. To give us a bit more access, it's a good idea to take this front panel out. There's two handles that just sort of lift and twist, and then lift and twist, and sort of lift out. Let's get a flat bladed screwdriver and just flick this circlip off. So now to get the carousel out, you just have to push this lever in there, get your hand under that and lift it away. There we go. Underneath the carousel lives this big wafer switch. And this is carried around as the carousel rotates, and these contacts here make the connections from the outer ring to each one there. You can see how sort of dirty these tracks are. They should be a nice shiny brass coloured, and you can see how it's all manky. So we're going to give those a good clean up, and that should make this far more reliable. First just going to give it a little brush off, just get the loose bits of dust and muck out of there. A little squirt of isopropyl alcohol. Let's get this, clean it up with a fairly stiff brush. We want to do the same by cleaning underneath these contacts. You can actually remove it by just taking this screw off. And the lip to the washer, set that down there. This just lifts off. Now you can get to these contacts and just clean all the sort of muck off there in the same way. There's a load of plugs underneath the carousel on this, and the best got at from behind. Fortunately they've put this little access panel, you just pull it open and you can get to all these nuts and fasteners. The plugs are funny little valve based type things. I'm not sure what they are, but they're pretty good. That's all the wires disconnected, I think. Time to just pull this out and put it on the bench. So the service is going to be basically like cleaning and lubricating all the moving parts. See if we can deal with this horrible scratching noise. I'm going to take this assembly off here. Running this, there's quite a lot of dirty contacts. There's some brass plates in there that have gone totally black, and lots of little contacts have gone black. Loads of cleaning to do. And this is the source of the horrible squeak. These brushes on these like rings here, which are filthy. So I'm going to hit it with the IPA again. A good way of cleaning the contacts without taking it all apart is to actually just get a piece of card or thick paper and slide it underneath the contacts so they just run over it, and then that gives them a bit of a scrub. So that's done a nice job. Look at all that muck. Now to do with that horrible squeaky noise. It's not as bad as it was, but it's still going to squeak because you've basically got metal on metal contact. Basically we can just lubricate it with some oil. I think there's a lot of hoo-ha about different lubes for this sort of thing, but really it just needs to be an oil. Now, no oils conduct electricity pretty much. They just need to be thin enough that the contact pressure, the spring pressure, will push the oil out the way. I tend to use a light machine oil in a little applicator like this with it's like a syringe needle, so I can really get into little fine places, because you don't want to put too much in. Bit on there, and the interior track. Turn it round a few times. Oh. So that's got a little bit of light lube on there, just to prove the point that it's electric okay. I was going to measure the resistance from the outer ring to the little tag on the wiper there. 0.1 ohms. The next one, 0.1 ohms, and the next one, 0.1 ohms. There's a theme here. It means it's perfectly good. Whilst I'm in this part of the machine, I'm just going to just lubricate the pivots for these little flipper things, whatever they are. Just checking all the other contacts and micro switches that I see about. Just check that they're okay. Don't know which is the right end. No. 0.9 ohms. That's okay. 0.19. Yeah, perfect. This loading motor mechanism looks lubed enough to me. It's got plenty of grease on there, and it's nice, still soft. It hasn't gone sticky or nasty, so I'm going to leave well alone there. Don't invite trouble. This is the top of the mechanism that we fetched off earlier. You can see this ring here that lifts up and down to make contacts here. These contacts here, you see, they're completely black. So we're going to give those a clean as well. I think that's all the contacts cleaned up that we need to do. There are contacts under this part as well, but I can actually see through there. They look really clean. I think it's because at the very bottom there's less, or whatever causes that corrosion to go on. So I'm just going to put this back on there now. I'm going to give this a bit of a wipe over just to get the muck off it. Make it look a bit better. Now that's cleaned up nicely, no more screechy noises. Lovely. I'm just going to jam this up out of the way, just find some way of wedging it there. Keep it out of the way. And I'm going to put the carousel back on. Ooh, lively. I'm going to make sure it lines up with this bit of a peg there on that. Slide it over the spindle. Ooh. Pull that back. So that's the bottom section back in and serviced. It seems to be holding up okay. Another thing I've noticed for this jukebox is it seems like none of the lights come on. If I make a selection, it's sure it's doing its thing, but there's no lights on. We've either got a lot of bulbs gone or something more common to it. These bulbs are dodgy. Oh, well no, not the bulbs, the holder's dodgy. I wonder if this theme is throughout the jukebox. I've just had a count, there's 27 of these to get sorted. I think the best thing to do is actually take all these bulbs out. They're on little panels and there's only a few nuts to undo, but there's a lot of wires. And this is the bulb panel. You can see the tracks all black, just like all the other switches were. Here we have a problem. This resistor's pretty much burnt out. That's probably why none of these bulbs work. Best thing to do here is unscrew all of these. Let's get that off with the soldering iron. We fetched the bulb panels out, little bulb circuit boards out, and we found that the it's all sort of corroded and black's a bad connection. We've also got a burnt out resistor on here. It's burnt out, so you can't actually tell what value it is. The colour bands are gone. Had a look on the other board in similar sort of mucky state. This has actually got some different components on there, some little diodes, but it's of interest. Also burnt out resistor and another resistor that's not burnt out, which is 220 ohms. So I'm going to make a guess that that's what the other one is, because it does have a little red band on the edge, so stands a chance. Well, we know the drill now. Squirt some IPA on it. It's not come up as clean as I'd have liked with just the alcohol and the brush, so I'm going to use the fiberglass pencil on this, which we know works. So check the resistance just to make sure this was open circuit. This one measures yes, open circuit, and this one should be good. Yes, 220 ohms. Perfect. I'm going to replace these resistors because they're burnt out. I'm thinking to put larger ones on with a higher power rating, so they shouldn't suffer as much. Put a bit of fresh solder on this one just to get the heat into it easier. That should be more substantial, not burnout. Bit better. We'll check these diodes, check that they're all okay. Just found this horrible little bodgy bit that someone's done. I've extended a wire. Messy soldering. That's got to go. Not in this workshop. Now I've got the lamps working on there, all sorted. Now I can turn my attention to these speakers and then the amp, see if it is muffled or not. Right, I'm now going to do a frequency sweep straight into the right speakers, see if it's got a good response right from the bass notes all the way to the high frequencies. Let's see, so we're going to go down. Yep. That sounds good. This is now the right hand speaker. This is working fine. Nothing wrong with the speakers. Now the speakers are all sorted, but the only thing left that matters on this is the actual amplifier. So I'm going to fetch the amplifier module out and just give that a check over, just check everything's good and healthy in there. Then this thing's pretty much done. One of the jobs I want to do with this jukebox, now the amplifier's out, is replace the mains cable. That cable's been on there for about 40 years and it's been run over several times. So although it's okay to power up in this controlled environment, I'm going to replace that. It's one of the first things I'm going to do. We'll start off, just snip that off here and here. I don't expect there to be much wrong with this at all, although the capacitors are, which are very commonly replaced, though they're quite old, they're not under a lot of stress in these applications. Probably more of an issue if they're in the signal path, which sometimes they are, because if they degrade you might lose some frequency response. So I'm just going to give this a bit of a check over, just check the components are good and fresh, and I think that's it really. Because I don't have the service manual for this amplifier, I'm not actually sure what the bias current should be, so before I start messing around with it, I'm just going to put the power cable back in and power it up and just make sure my measurements, measure the voltage drop across the emitter resistors, which are the chunky white ones in the all in a row there. That'll give me a good indication of what the the idle current of the amplifier is, so when I have messed around with it I can make sure it's back to something like it should be. We'll do the neutral wire first. Oh, fuck's sake. And the live wire. And then the stripy one. Which goes down here. I'm going to power it up using this safe block because I've got to, if I put the plug on I can't thread it through the back of the jukebox, so it's a little time saving little hint. Right, the power's on this now. I'm just going to make some measurements. The main bulk capacitors are the interesting ones, what the main voltages this runs on. And we've got minus 30 and plus 30. Now I know how to power it up off the power supplies if I want to go playing a bit more with it. Whilst I'm here, I'm going to make a note of what the idle current is for each of these resistors. If I measure across there, it's going to be some millivolts. So this one, minus 3.6. Minus 4. I'm not reading too much into the negative aspects of this. It's just which way around I got the leads. And we got 4.9, and this one is 6.9. 4.9 and 6.9. A little bit out, but they're around where I'd expect a safe level for the current drive through this. Typically on a transistor amplifier you'd have a idle current of in the order of, like, 10, 20, 30 milliamps. Higher than that, you're talking audiophile stuff. Whilst I'm measuring this, I might as well check where the ripple is. So if I move the meter to the AC voltage and just measure across those main capacitors and see what ripple we've got. And we've got 50 millivolts RMS on that one, and the same on this one. There's not much ripple. I don't think these caps are too bad at all. I'm going to check the capacitors with an Esr meter, which just checks how well they pass AC currents, which is a good indication of how healthy they are. They're a great little tool because it saves having to unsolder every component. But before you use it, especially after having powered the amp up, you should check that the capacitors are discharged. So I'm just going to use this discharging tool just to check for any residual voltage. And yeah, this thing's pretty. Yeah, there's nothing hanging around here, so it's safe to use. So the Esr meter, this one actually, this is a homemade one, so you can buy them or you can make them yourself. They use they're quite a simple circuit really. But you're looking for something like a short circuit or the equivalent of a short circuit. If I start from this end, it's good for all the electrolytics. You should be looking for something, good high readings. So these are good. Oh, yeah, nothing wrong here. They're all good. They're all good. So, not a surprise really for an amplifier that actually works. There's nothing really wrong with it. Check through all the capacitors. They might be old, 40 years old, but they still function perfectly well. So you could change them if you wanted, but you would actually not gain anything. I mean, they might last longer, so I don't know if they'll still be good in another 10 years, but as of today they're fine. I'm going to put this back together. I'm going to feed the mains cable back through the gap there. That'd be embarrassing to forget. It's coming back together nicely now. Got the counter back on, really good. So what I've got to sort out now is the lock. I need to open the hole up because the new lock is a bit bigger. So I'm just going to put this bit of a cover over here just to catch the swarf. Don't want to ruin the good job I've already done. So I'll get this lid to stay down. I'll try clamping it to the frame there. Nice job. I hope that's it now. I'll try it. Oh, what the fuck? There's a cable tie on the contacts, for fuck's sake. Well, that's the Niagara 2 done. Gonna tidy this workshop up now. Catch you next time.